Hello student, in this video we'll see revision and MCQ questions on the properties of the liquid. To understand the properties of the liquid, majorly there are two properties of the liquid. First one is the viscosity and second one is the surface tension. So in the viscosity, the first part, that is the pressure. What is meant by the pressure? Pressure means force per area, and this force per area, and due to this pressure we get one first concept, that is the total pressure at the depth h from the free surface of the liquid. And this pressure, total pressure, is equal to algebraic sum of atmospheric pressure, P naught is the atmospheric pressure, plus h rho g, this is the pressure due to the depth of the body. So this h is the height of the body from the free surface of the liquid, this rho is the density and g is the gravity. So this atmospheric pressure acting on the free surface of the liquid, this is equal to 1.013 into 10 raised to power 5 Newton per meter square. So this is the pressure acting on the body at a depth h from the free surface of the liquid. Second part, that is the concept of gravity acting on the free surface of the liquid. So the pressure difference between the point which is at the free surface and which is at the depth h, this P2 minus P1 is equal to h rho g. And in this case, in the absence of gravity, the pressure P1 and P2 is equal, means pressure at every point inside the liquid in equilibrium it remains same. So this is the second concept. Third one, that is the coefficient of viscosity. This is very important, this topic. To understand this coefficient of viscosity, we have to know the two concepts, that is the streamline flow of the liquid and turbulent flow of the liquid. When the liquid in motion, then the velocity of the liquid at any given point it always remains constant, both in magnitude and the direction. This type of the flow is known as streamline flow. And second one, the turbulent flow of the liquid, means the velocity of the liquid at any point does not remains constant, but it changes with respect to its magnitude and the direction. This type of the flow is known as turbulent flow. As well as what is meant by viscous force. Viscous force means the force between two adjacent layers of the liquid which oppose the relative motion between these two layers of liquid. This force is known as viscous force, and this viscous force is directly proportional to this viscous force. This F is the viscous force, and this viscous force is directly proportional to the area of the layer which are in contact, as well as it is also directly proportional to the velocity gradient. Velocity gradient means the rate of change of velocity with respect to the distance measured from its stationary layer is called as velocity gradient. Means when liquid in motion, the velocity of bottom layer is equal to 0 and the velocity at the topmost layer is a maximum, and this gradient is known as velocity gradient dv by dx, and this proportionality constant is known as coefficient of viscosity. The unit of this coefficient of viscosity is the Poise. Next concept, that is the terminal velocity. What is meant by terminal velocity? When any spherical body pass through the liquid, it experience some force, viscous force in the motion of this body, and initially this force or initially the velocity of the body is get continuously changes, but after some time the velocity of this spherical body through this fluid, through this liquid, is remains constant, and this velocity is known as terminal velocity. To understand the concept of terminal velocity, this is we just compare the total upward force and total downward force. This equation is important to solve, to calculate the density of the liquid as well as to calculate the coefficient of viscosity. This concept is nothing but the viscous force. According to the Stokes law, when any body pass through the liquid, small spherical body pass through the liquid, then the viscous force acting on this body is directly proportional to the coefficient of viscosity as well as radius of the spherical body and the velocity of this body. So this is viscous force, and this is the force due to the liquid, and this is the force of this body, or you can say that this is mg. Put the value of m is nothing but volume into the density. This rho is the density of the spherical body, this sigma is the density of the liquid. So this is the very important equation, and which is related to the terminal velocity. Next part, that is the Bernoulli's principle. What is meant by Bernoulli's principle? Bernoulli's principle is related to the kinetic energy, potential energy. So what is the statement of Bernoulli's principle? For the streamline flow of non-viscous liquid or incompressible fluid, the sum of pressure energy and the kinetic energy per unit mass and the potential energy per unit mass is always remains constant, and this is equal to pressure energy. This term is due to the kinetic energy per mass, and this is potential energy per mass, and this algebraic sum of these three type of energy, pressure energy as well as kinetic energy plus mass and the potential energy per mass, is remains constant. This concept is known as Bernoulli's principle. This Bernoulli's principle is required to find out the velocity of this fluid as well as to find out the density, to find out the pressure. Next one, next concept which is related, or this is the statement of this Bernoulli principle for the streamline flow for non-viscous and incompressible fluid. This algebraic sum of these three type of energies remains constant. Next concept which is related to the surface energy. So see here, this surface tension. What is meant by surface tension? Surface tension is the property, and it is due to the force between the atoms, or you can say that intermolecular force, and due to this intermolecular force, the new concept, that is the surface tension. So what is the surface tension? The surface tension is the potential energy per increasing area, or you can say that work done per increasing area, and it is also force per length. Unit of the surface tension is Newton per meter. Then to understand the surface tension, there is a one concept known as angle of contact. So what is meant by angle of contact? Angle of contact means when solid and liquid in contact with each other, then the angle between the surface of the solid and tangent drawn to the surface of the liquid towards the liquid side is called as angle of contact, and this theta is known as angle of contact. So to derive this equation, surface tension, by the capillary action, you know that the capillary action, what is meant by capillary action? Capillary action means the increase or decrease of the liquid inside the capillary tube is known as capillary action. And according to the capillary action, the surface tension is equal to H is the increasing height of the liquid, rho is the density of the liquid, G is the gravitational acceleration, R is the radius of capillary tube, and this theta is known as angle of contact. So this equation is also important to find out the surface tension of any type of liquid as well as height, increasing height through the capillary tube, the radius of this capillary tube. We'll see some MCQ also. Then another one law known as Laplace law. Laplace law is related to the difference in pressure. This Pi is the internal pressure and this P naught is the atmospheric pressure, is equal to 2T surface tension upon the radius of this spherical bubble. Stokes law, that is the viscous force. This Stokes law is related to the viscous force acting on the spherical body through the liquid. This 6 pi is the constant, eta is the coefficient of viscosity, r is the radius of the spherical body, and v is the velocity of the spherical body. Then critical velocity in terms of Reynolds number. So this critical velocity means the velocity of this body through the liquid when it is remains constant, it is not changed, is known as critical velocity. And this critical velocity is equal to n means Reynolds number, it is remains constant, eta is the coefficient of viscosity, and then rho is the density of the liquid, r is the radius of this spherical ball. So this is the some theoretical part of this properties of the liquid. Then after this we'll start some MCQ parts of this liquid. So first question, we'll see the first question number 1, and this question number 1 is related to the pressure depth. So what is the question number 1? If the pressure at the half the depth of lake is equal to 2/3 pressure at the bottom of the lake, then what is the depth of this lake? What is the given condition? This is according to the pressure equation, P is equal to P naught plus EH rho G. Then compare the two condition. The pressure at the half of the lake is equal to 2/3 of the pressure at the surface of the liquid, that is P naught plus EH rho G. This is at the half of the liquid and this is on the surface of the liquid, or the bottom of the, this is not surface, this is at the bottom of the lake. So compare these two equation, we get P naught is equal to P naught by 3 is equal to 1 by 6 H rho G. So H is equal to, you have to calculate the depth of the lake. So H is equal to, put the value of this P naught atmospheric pressure, it is nearly equal to 10 raised to power 5. Density of this water liquid, it is given 10 raised to power 3 into G is nearly equal to 10. So height or the depth of this lake is 20 meter. So for this question number 1, the correct option is B. Answer is 20 meter. Next one, question number 2. Two bodies are in equilibrium when suspended in water from the arms of the balance. The mass of one body is given and this mass is equal to 36 gram and its density is 9 gram per centimeter cube. If the mass of the other body is 48 gram and its density is, so two bodies which is connected to the two arms of the balance and it is in the water, mass of two bodies given, then calculate the density of the second body. So we just use this concept, that is the apparent weight of the body in a liquid, this is mg. Write down this m, volume into the density, difference in density, rho is the density of body minus density of the liquid or the water. So put the value of volume, it is mass per density, rho minus sigma into G. So compare this equation for the two body, for the first body m1 and for the second body m2. Put the value of mass of the first body is 36, density of the first body is g, this is 9, then again 9 minus 1, this is gg is the gravity, it is get cancelled. Mass of second body is 48, density, calculate the density of second body. Then simplify this equation, it is 36 upon 9 and it is equal to 6 upon rho 2. Again simplify it, 36 upon 54, and finally we get the density of the second body is equal to 3 gram per centimeter cube. So answer or the correct option for question number 2 is C. Next one, next question, we'll see the question number 4. So to understand this question number 4, what is the given things? The height of mercury barometer is 75 centimeter at the sea level and 50 centimeter at the top of the hill. The ratio of density of mercury to that of the air is 10 raised to power 4. Then height of the hill is, we just use this concept. This is the case for sea level, equation number 1, and equation number 2, this is the case for the atmosphere. So this is difference in height in sea level and h in the air level. So compare these two equation, we get gg get cancelled, so you can calculate the height, h is equal to, this is height of the hill, put the value, this is 25 into 10 raised to minus 2, convert this centimeter into the meter, ratio of this density is given 10 raised to power 4, simplify it, we get it is 2.5 kilometer. So correct option, option number, for this question number 4, the correct option is option number B, that is 2.5 kilometer. Next one, that is question number 6. In the question number 6, a liquid is kept in a cylindrical vessel which is being rotated about the vertical axis through the center of circular base. If the radius of this vessel is r and angular velocity to rotate is equal to omega, then center of vessel and the edge is, use the Bernoulli's theorem to calculate this, use the Bernoulli's theorem. So two cases, pressure, and in the second case the pressure in the rotational equation, so Pa minus Pb, it is equal to 1/2 rho Vb square minus Va square. So compare these two cases, one is for the vessel which is rotate about the vertical axis, and second one is at the rest. So we get the difference in velocity, Pa minus Pb is h rho g, this is according to the pressure difference equation. Va is equal to 0 at the rest and Vb is rotate with r omega. So h is equal to r square omega square upon twice g. Put this value or put this given condition value in the last equation, simplify it, we get the h value, put the difference, Pa minus Pb is equal to h rho g, so h is equal to r square omega square upon twice g. So for this question number 6, correct option is B. Next one, question number 7. For the question number 7, two capillary tubes of the same diameter are kept vertically, one each in the two liquid. Its two density of this two liquid is given 0.8 and 0.6, and the surface tension are 60 and 50 dyne per centimeter respectively. Then the ratio of their height of the liquid is, so according to the surface tension equation, h is equal to twice t cos of theta upon r rho g. Write down the ratio of height h1 by h2 directly proportional to the tension, inversely proportional to the density. So put the value of ratio of surface tension 60 upon 50 as well as ratio of density 0.6 upon 0.8. We get the final answer 9 upon 10. So correct option for question number 7 is option number D. Next one, question number 10. In question number 10, two soap bubbles are there. One of radius 50 millimeter and second one is the 80 millimeter. Are brought in contact to the common interface. Then the radius of curvature of common interface is, use this Laplace law, Pi is equal to P naught plus 4T upon R. This 4 is due to the soap bubble. Then compare the equation for first case for the first bubble and second bubble. Then we get the total radius of the this resultant bubble or the common interface 1 upon R is equal to 1 by R2 minus 1 upon R1. This is the equation of first bubble. Second similar equation for the second bubble. Then compare these two equations, we get the equation in terms of radius. So R is equal to, put the value of R1 R2 as well as the difference, we get the radius of this common interface is 0.133 meter. So for the question number 10, the correct option is option number B. Next one, question number 20. In the question number 20, what is the given things? Water rise to a height of 10 centimeter in a capillary tube. H is given and it is equal to 10 centimeter in capillary tube. And mercury falls to the depth of 3.1 centimeter in the same capillary tube. If the density of mercury is 13.6 and angle of contact for the mercury is 135 degree, then the ratio of surface tension of water and mercury. So write down this equation for the water and the mercury. We get the surface tension is proportional to H rho and inversely proportional to the theta, because theta value is also given. So write down this ratio. Height is directly proportional, density is also directly proportional, but this cos theta is inversely proportional. So whatever the given things, height in water 10, height in mercury it is 3.1, as well as ratio of water, this density of water is 1, ratio this density of mercury is 13.6. Write down its ratio. This angle of contact through the mercury and angle of contact through the water, the angle of contact in water is 0. Simplify it, we get the ratio of the surface tension is 1 by 6. So for question number 20, the correct option is option number C. We'll see the next question, that is question number 23, which is related to the surface tension or the terminal velocity. A small metal ball of diameter 4 meter and density 10.5 gram per centimeter cube is dropped through the glycerine of a density 1.5 gram per centimeter cube. Then the ball attains the terminal velocity of 8 centimeter cube. Then the coefficient of viscosity. Write down the equation of coefficient of viscosity in terms of radius of the ball, in terms of density of the body, and rho dash is the density of this glycerine, G is the gravity, and this is 9 V naught. V naught is the terminal velocity. 2 R. R is given, that is the 2 meter. Then put the value, it is, simplify it, the density of the glycerine, density of this metal sphere is 10.5 and glycerine 1.5. So put the value as well as 9 into 8. So 8 is the terminal velocity. Calculate it and final answer is 9.8 poise. The coefficient of viscosity of this glycerine is 9.8 poise. So for this question number 23, the correct option is Option number B. Next one, that is question number 24. In question number 24, n drops of the water, each of radius 2 mm, falls through the air at a terminal velocity 8 cm per second. If these coals together to form a single drop, then the terminal velocity of combined drop is 32 cm per second. The value of number of droplets, that is calculate n by using or compare this volume of single droplets and n number of droplets. We get the equation of capital R, the radius of the coals drop as well as radius of the n number of droplets, and write down the ratio of its terminal velocity, because this terminal velocity is directly proportional to the radius of droplet, square of radius of the droplets. So V naught dash R square, V naught proportional to R square. Put the value of capital R, it is n raised to power 1 by 3 into small r and its square. Then this is 32 upon 8 terminal velocity for these two droplets is given. So simplify it, we get 4 raised to power 3 by 2, square root of 4 is 2 and its cube is 64 and its square root is 8. So for question number 24, the correct option is D. Next one, we'll see the next question, which is related to the next topic, that is the surface tension. That is the question number 40. Again, this question number 40 is related to the capillary action. So what is the question? If the surface tension of the water is 0.06 Newton per meter, the excess pressure inside the water drops of the diameter 1 millimeter is. Water means the angle of contact is equal to 0. Surface tension is also given. What is the surface tension? 0.06 Newton per meter, as well as theta is also equal to 0. Radius of this water drops is given 1 millimeter, so it is 0.5. Radius, this is 1 millimeter is the diameter, its radius is 0.5. Density of the water is 10 raised to power 3, and this is conversion of millimeter into the meter. Then G value 9.8. Simplify it, we get 2.44 centimeter. So for the question number 40, the correct option is option number B. Then question number 41. Next question, that is the question number 41. In the question number 41, what is the excess pressure inside the drop of mercury of radius 3 millimeter? What is the excess pressure? Means it is related to the Laplace law. The Laplace law, P is equal to twice T upon R. Surface tension is given, radius of this bubble is also given, drop of mercury, it is 3 millimeter. So surface tension is 4.65 into 10 raised to power minus 1. Put the value, we get the excess pressure, it is 310 Newton per meter square. So for the question number 41, correct option is option number E. Next one, question number 43. Two horizontal pipes of radius 1 centimeter and 2 centimeter are connected with one another. What is flowing through them? Water is flowing through them. If the velocity of the water in the first pipe is 8 meter per second and the pressure is atmospheric pressure, then the pressure and the velocity of the water in the second pipe is given. This concept is related to the venturimeter. So by using the concept of continuity of the equation, area of the first pipe, velocity of the first pipe, A2 is the area, cross-sectional area of second pipe, and V2 is the velocity of water through the second pipe. So compare this, we get ratio of its velocity and ratio of cross-sectional area. So final conclusion, the ratio of velocity is directly proportional to the radius of the pipe, square of radius of the pipe. So V2 is equal to, calculate the velocity of this water through the second pipe. It is equal to 2 meter per second. Then next one, to calculate this, so we get the first thing, that is the velocity. To calculate the pressure, use the Bernoulli's theorem. P2 is equal to P1 plus 1 half rho V1 square minus V2 square. The concept of this venturimeter. This pressure is 10 raised to power 5. 1 half rho is the density of this water. Velocity difference 64. Its square 8 meter per second. So 64 its square, and 2 meter per second. So it is 4. Find out this value. We get 1.3 into 10 raised to power 5 Newton per meter square. So for question number 43, correct option is option number C. Next one, question number 49. In question number 49, a metal block of density 5 gram per centimeter cube and having dimension 5 length, 5 centimeter length, 5 centimeter breadth, and 5 centimeter height is weight in a water, its apparent weight will be. So we can write down this apparent weight is mg. M is the volume into the difference in density. So put the value of volume, it is 5, and the difference in density into g. So we get 4 into 5 raised to power 3 g. So correct option for question number 49 is D. Next one, question number 55. In question number 55, two different liquids are flowing in two tubes of equal radius. The ratio of coefficient of viscosity of the liquid is given 52 as to 49, and the ratio of their density is 13 as to 1. So two values are given, coefficient of viscosity ratio as well as density ratio. According to the critical velocity in terms of Reynolds number, in terms of coefficient of viscosity, critical velocity is directly proportional to coefficient of viscosity, inversely proportional to the density. Then write down this ratio, put the value of coefficient of viscosity and the ratio of density. We get the ratio of this critical velocity is equal to 4 by 49. So for this question number 45, the correct option is option number A. Similarly, we'll see the next question, question number 58. A manometer connected to the closed tap reads 3.5 into 10 raised to 5 Newton per meter square. So by using manometer, we get the pressure. When the valve is open, the reading of manometer falls to 3 into 10 raised to power 5 Newton per meter square. The velocity of flow of water is, I can use the Bernoulli's theorem for the two different cases. Before, when the valve is closed and when the valve is open, this is the square of velocity. So difference in pressure for the first case and second case. Compare this equation for two different cases. We get V square is equal to, only due to the close and open the valve, pressure gets changes, velocity of the water is remains same. So we get V square is equal to twice of P1 minus P2 upon rho. So 2, put the value of difference in pressure 0.1, 0.5 into 10 raised to power 5. The density 10 raised to power 3. So we get square, V square is equal to 100. So V is equal to 10 meter per second. So correct option for question number 58 is B. Next one, question number 68. In question number 68, no 64. In question number 64, water rise to the height of 10 centimeter in the capillary tube and mercury falls to the depth 3.5 centimeter. The density of mercury is given 13.6, the density of water is 1, then angle of contact for mercury is 135 degree, water is 0 degree, then the ratio of their surface tension. So write down this equation of height. According to the capillary action, surface tension is directly proportional to the height, as well as it is also directly proportional, inversely proportional to the T is directly proportional to H, as well as it is also directly proportional to the rho. So write down this ratio of height as well as the density and this angle of contact. Put the value, we get the ratio of this height is also given. Put the value of this ratio 10 and 3.5. Density is 30.61 and the density of water is 1. Then angle of contact for the water is 0 and angle of contact for this mercury is 35. So just put the value of this ratio, we get the answer of this question number 64 is 5:34. So correct option for question number 64 is option number B. So this is the part of the properties of the liquid, and when you see carefully, this properties of the liquid is mainly focused on the two concepts. First concept, that is the viscosity. In the viscosity, that is the coefficient of viscosity concept, terminal velocity, critical velocity, as well as pressure acting on the body at the depth h from the free surface of the liquid, and also related to the venturimeter as well as Bernoulli's principle. This is the first part of properties of the liquid. And in the second part, that is the concept of surface tension. You know that in the surface tension, that is the surface tension concept, then angle of contact, then capillary action, as well as the Laplace law. All these MCQs depends upon these 4 to 5 topics. So in this way you can solve the different number of MCQ. Thank you.